Prep 2. I hope you are all okay. Today we'll continue our lesson or our course. Unit 2, Lesson 1, Properties of Sound Waves. Any sound that we hear has many properties. For example, the sound that we hear may be a musical tone or a noise. Musical tone like piano, guitar, violin, etc. They have a uniform frequency. They have a sequence. Noise, they have a non-uniform frequency like drill and hammering, okay? Unit 2, Lesson 1, Properties of Sound Waves. First point, sound. What's meant by sound? When we hear something, an energy comes to our ear. This energy is called sound energy. So sound is an external factor. It comes from outside, external factor, which affects on ear, causing sense of hearing. Sound is an external factor, affects on ear, causing hearing. Like this, the sound waves come and enter through my ear. Sound originates due to the vibration of the objects. When we make a vibration like this, we hear a sound, okay? So it originates due to the vibration of objects. And also, as we studied before, that sound waves are mechanical waves because they need a medium, they can't propagate through space, and they are longitudinal waves because they are composed of compressions and rarefactions, and they move in all directions. When I talk, the person behind me can hear me, the person upside, downside, in all directions you can hear me, okay? Because sound waves, they move as spheres in all directions formed of compressions and rarefactions like this. The sound source in the center and the compression and rarefactions in all directions forming sound waves. Sound velocity. What's meant by velocity? It means speed. To measure the sound velocity as it's a wave, we have to multiply frequency times the wavelength. For example, I have a problem. If the frequency of a sound wave is 200 hertz and the wavelength is 1.7 meters, calculate the sound velocity. Velocity equal frequency times wavelength, as we said in law of wave propagation. Frequency equals 200 hertz times wavelength, which is 1.7 meters. So the velocity will be 340 meters per second. The properties of sound. Any sound that we can hear has three main properties, which are sound pitch, sound intensity, and sound quality. Three main properties. Each one differentiate or allows us to differentiate between two properties. For example, sound pitch of any sound allows me to differentiate it's a sharp sound or a harsh sound. What is the difference between sharp and harsh? Like the difference between sound of a sparrow or a bird and lion, women and men. Okay, sound intensity, it allows us to differentiate between the sound is a strong sound like shouting or a weak sound like whispering. And sound quality allows us to differentiate between different sounds. For example, when I hear a specific sound, I can say this is Ali or Amira or whatever as a person. Okay. The first property, sound pitch. A property that allows us to differentiate between sharp sounds and harsh sounds. Okay, according to what? According to their frequency. The main point in sound pitch property is the frequency. So, for example, I have two types: sharp sounds, high-pitched sounds, and harsh sounds, low-pitched sounds. Sharp sounds like woman voice, birds, violin, piano. Sharp sounds, okay? Harsh sounds like men voice and lion voice, hammering, harsh sounds. They are low-pitched and they are high-pitched. What's the difference? They have high frequency and they have low frequency. Sound pitch property depends on sound frequency. For example, a sharp sound or high-pitched sound and harsh sound or low pitched sound. What is the difference? In case of sharp sounds, they have, or the sound waves have, high frequency and low wavelength. As we studied before, that frequency and wavelength are inversely proportional. When the frequency increases, the wavelength decreases, and vice versa. Harsh sounds, they have low frequency and high wavelength. Okay, in a graph like this, these waves produced from a source, it's a sharp or harsh sound? Sharp sound. Why? Many waves, so the frequency is high, and the low wavelength is small waves. Low wavelength or small waves. In case of this one, small amount of waves or a small number of waves, and in this case the frequency is low and the wavelength is high. So this one is harsh sound and this one is sharp sound. Sharp and harsh sounds as well. If I have two bottles of water, one of them is almost completely filled and the other one is filled with a little amount of water, and we blow air in both bottles, okay? As the length of air column decreases, which means the water level increases, the sound will be sharper or has a high pitched sound property, okay? The sound frequency increases, so when the length of air column decreases, a small amount of air in the bottle, the frequency will increase, and so the sound will be sharp. So the sharpness of sound increases as well. Harsh sounds, as the length of air column increases, the air inside the bottle increases, so a small amount of water. As the air increases, the sound will be harsh sound. Okay, the sound frequency will decrease and the harshness of sound will increase. Note, sound pitch depends on the sound frequency. As we said before, sound pitch and the sound frequency are directly proportional. So for example, when the frequency increases, the sound pitch will increase and it's a sharp sound. Again, when the frequency increases, the sharpness of sound increases and harshness decreases. Okay, so for example, women has a high-pitched sound. They produce many waves when they talk, so we hear a sharp sound. On the other hand, men, they have a harsh sound, as they produce a little amount of waves or a little number of waves, smaller number of waves, so they have a smaller frequency and so their sound is harsh sound. When the sound frequency increases, the sharpness will increase, for example like women's voice, and the harshness will decrease. When the length of air column increases, more air inside the bottle, the sharpness will decrease because the frequency will decrease and the harshness will increase. Sound frequency is measured by a tool called Savard's wheel. Practically, to measure the frequency of any heard sound, if I heard a sound in the street and I want to know its frequency, okay, I can use a tool which is called Savard's wheel. It's a tool like this, okay? I have an arm to rotate and I have two gears with different number of teeth, okay? And I will bring a metallic piece, a small metallic piece, and put it like this, and I will make cycling till I hear a sound similar to the sound that we heard in the street, okay? When I hear the same sound, I have to measure the frequency, and the frequency equals the cycles that we made times the number of teeth in the gear that we used over the time of cycling, the time that we took to make cycles or to get the frequency or to get the same sound. Okay? For example, I have a problem. Calculate the number of teeth of a gear used to get a 100 Hz sound by making 300 cycles in 2 minutes. Okay, the time must be in seconds. To measure the N, which is the number of teeth, N equal frequency times the time taken over D. frequency is 100 hertz, and the time is 120 seconds, not 2 minutes, over 300 cycles equals 40 teeth. For example, this one, not this one. Okay? Sound intensity, the second property of sound. We have finished the sound pitch property that helped us to differentiate between sharp sounds and harsh sounds according to the frequency. Now we will talk about sound intensity. Sound intensity is a property of sound that is measured in watt per meter square. Its measuring unit is watt per meter square, and it allows us to differentiate between strong sounds like shouting and weak sounds like whispering or talking without shouting. Whispering has less intensity than shouting. Sound intensity has another name which is called sound volume, like the volume of sound in TV. When I increase the volume, I'm increasing the sound intensity. I will hear a higher sound. Okay, so sound intensity allows me to differentiate between strong and weak sounds. Note, noise intensity is measured in decibel. When we hear a noise, a loud noise, it's not measured in watt per meter square, it's measured by decibel. I have 5 factors affecting sound intensity. In case of sound pitch, we had only one factor, which is called frequency. In case of this, we have 5 factors affecting sound intensity, which are the distance between the sound source and the target, between me and you, for example, to talk. Okay. Number 2, the amplitude of the sound waves. Number 3, the area of the vibrating surface. Number 4, the wind direction. I'm talking in the same direction of winds or opposite direction of winds. Number 5, the density of medium. Okay, we have to remember sound intensity means the level of sound. Level, okay, a high sound or a low sound, for example. First factor is called distance. Logic. As we move away from the sound source, we will hear less. Okay, as we move away from the person who talks, we will hear him less. Okay, so as we move away from a sound source, the distance will increase between me and the sound source, but the sound intensity will decrease. So the relation between distance and sound intensity is inverse, not direct. For example, sound intensity is inversely proportional to the square of the distance, not to the distance, to the square of distance. So, for example, as the distance increases to double, sound intensity will decrease, but not to half, it will decrease to quarter. When the distance increases to double, the sound intensity is inverse with the square of distance. Okay, so sound intensity decreases to half and another half due to the square. So it decreases to quarter. So when the distance increases to double, sound intensity will decrease to a quarter. Number 2, sound amplitude. Sound intensity is directly proportional to the square of amplitude. So for example, when we check small amplitude, larger amplitude, larger amplitude. The last one has the highest intensity, and this one has the smallest intensity. Okay, so they are directly proportional. As the amplitude increases to double, the sound intensity will increase to 4 times, not only double. Why? Because sound intensity is directly proportional to square of amplitude, not to the amplitude only, to the square of amplitude. Point number 3, area of the vibrating surface. As the surface area of vibrating surface increases, the sound intensity increases as well. For example, if I have a tuning fork, okay, and when we hit the tuning fork, it will make a sound, but we will fix it on a resonance box, an empty box, okay, or inside a cup, and we hit the tuning fork, it will produce a higher sound intensity. Okay. Density of the medium. As the density of medium increases, the sound intensity increases as well. As the density of medium increases, the sound intensity increases. Sound has more intensity in carbon dioxide than in air. Why? Because carbon dioxide has a higher density than air. So when the density of medium increases, the sound intensity will increase as well. And that's why the velocity of sound is smaller in air than water than solid. Solid is denser than liquid, so air moves faster and stronger. So sound moves faster and stronger in solid than in liquid. The last point, wind direction. When we talk and in the same direction of winds, the sound intensity will be more than talking in opposite direction of winds. Like this example, this person is talking and the sound reached this one, for example, while in this case the sound didn't reach because he is talking in the opposite direction of winds. Sound intensity increases in this case and sound intensity decreases in the other case. Thank you for listening. I hope you enjoyed, and thank you.